trigonometric identities. Can someone remind us why these identities are important?
Good question. Trigonometric identities help simplify expression, transform one function into another, and solve equations. They are also useful in real-world applications like physics and engineering.
Right. For example, in electrical engineering, sine and cosine function describe alternating current A or C waveforms. Using identities helps simplify complex calculations.
That makes sense. Let's apply the fundamental identity to express one trigonometric function in terms of another. How can we express sine squared theta in terms of cosine squared theta?
We use the Pythagorean identity, which is sine squared of sine squared theta plus cosine squared theta, which is equals to 1. If we isolate sine squared theta, we get sine squared theta is equals to 1 minus cosine squared theta.
That's a great example. Here's another. How we can express tangent theta in terms of sine theta and cosine theta. We recall the quotient identity. Tangent theta equals sine theta over cosine theta. This is useful when solving equations involving tangent functions because we can rewrite them in terms of sine and cosine.
Let's try proving an identity. How about this one? 1 plus tangent squared theta is equals to secant squared theta.
That's a classic identity. Let's start from the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. Now let's divide everything by cosine squared theta to transform it.
Since sine squared theta over cosine squared theta is equals to tangent squared theta, and 1 over cosine squared theta is secant squared theta, we get tangent squared theta plus 1 is equals to secant squared theta.
That's correct. This proof is helpful when working with secant and tangent functions in solving equations.
Now here's the question. Why do you prefer proving an identity using algebraic manipulation rather than plugging in values?
Because proving identities algebraically ensures they hold for all values within the domain, while numerical verification only checks for specific cases.
Now, let's solve a problem using identities. Given that cosine theta is 3 over 5 and theta is in the first quadrant, since sine theta using identities,
We use the Pythagorean identity again. Sine squared theta plus cos squared theta is equals 1. Substituting cosine theta equals 3 over 5, we solve for sine squared theta. Sine squared theta plus 3 over 5 plus an open parenthesis and square equals 1. Sine squared theta plus 9 over 25, because we squared the 3 over 5 and it becomes 9 over 25 and equals 1. Sine squared theta is equals 1 and negative 9 over 25 equals 16 over 25. And the final answer are, we need to simplify this. So, sine theta is equals 16 are 4 and 25 are 5. So this is the final answer.
since theta is in the first quadrant, sine is positive and sine theta equals 4 over 5. That was straightforward using identities.
Here is a challenge. If we know sine theta equals 4 over 5, how can we find tangent theta?
We use quotient identity. Since tangent theta is equals to sine theta over cosine theta, and they are equal to 4 over 5 and 3 over 5, which is equals to 4 over 3.
That was a great example of solving values using identities.
This discussion really showed how trigonometric identities simplify expressions, prove relationships, and solve problems.
And the ability to prove identities strengthens our problem-solving skills.
Exactly! Let's practice more so we can apply these concepts in more advanced problems.